In this video, we'll continue talking about polar coordinates. Here is a summary of an equation of circles in polar coordinates. So r equals a, describe a circle of radius, absolute value of a, centered at the origin. The equation r equals 2a sine of theta also describes a circle of radius, absolute value of a, centered at c, 0a. R equals 2a cosine of theta describes a circle of radius, absolute value of a, centered at c of coordinates a0, and r equals 2a cosine theta plus 2b sine theta describes a circle of radius, square root of a squared plus b squared, centered at ab, like we've seen in the previous video. So let's continue by graphing in polar coordinates the function r, which is a function of theta, equals 1 plus cosine theta. So for that, we'll give some values. So if theta equals 0, r equals 1 plus cosine of 0. We need to know trigonometric functions very well. So 1 plus cosine 0 equals, cosine 0 equals 1 plus 1, which is 2. So we put 2 here. For pi over 6, it's 1 plus cosine pi over 6. And so it's 1 plus cosine of 30 degrees. It's square root of 3 over 2. So it's 2 plus square root of 3 over 2, which we can approximate to 2 plus 1.7 over 2, which is 3.7 over 2, which is 1.85. So 1.85. The next function, r equals 1 plus cosine of pi over 2, which is 1 plus 0, 1. R equals 1 plus cosine of 5 pi over 6. 5 pi over 6 would be 150 degrees, so the reference angle is pi over 6. All students take calculus, so that means cosine of 5 pi over 6, it's actually negative cosine of pi over 6. So we get 1 minus cosine of pi over 6 is square root of 3 over 2, so it's 2 minus square root of 3 over 2, which is 2 minus 1.7 over 2, which is 0.3 over 2, or 0.15. Then 0.15. The next one is r equals 1 plus cosine pi, so that is 1 minus 1, which is 0. Then the next one would be 7 pi over 6, so r equals 1 plus cosine 7 pi over 6, which is 1 plus, 7 pi over 6 would be this way, so this would be 7 pi over 6, which means this would be pi over 6, the reference angle. So again, minus cosine of pi over 6, because t stands for tangent, so cosine is still negative. Minus square root of 3 over 2, we already calculated this before here, so it's going to give us 0.15. Then 0.15 for 3 pi over 2, it's going to be this. 3 pi over 2, it's here, which is of coordinate 0, negative 1, so cosine would be 0, so 1 plus 0 is 1. Then 11 pi over 6 would be pi over 6 would be the reference angle here, so cosine of 11 pi over 6 would be the same as cosine of pi over 6. So we get 1 plus square root of 3 over 2, which we calculated before here, so it's 1.85. And then going back to 2 pi, 1 plus cosine of 2 pi is 1 plus 1, so it's 2. So now, having the table of values, let's plot them in the plane. So we have for 0 r, it's 2. So angle is 0, r is 2. I'm gonna count 1, 2 here. Then for pi over 6, it's 1.85. So pi over 6 would be here. So 1.85 would be here. Then for pi over 2, it's 1. For 5 pi over 6 would be 0.15. So that's closer to the origin. Then for pi is going to be 0. Then for 7 pi over 6 would be 0.15. So again 0.15 here. For 3 pi over 2 would be 1. For 11 pi over 6 would be 1.85. So around here. And then for 2 pi 2 back there. So now connecting the dots, we would have something like this as the graph of our function. So I'm going to check this with the calculator. So to do that, we open the calculator, then we go to mode, then we choose polar. Enter. So now we go to y equals, and our function was 1 plus cosine theta. Let's go back. 1 plus cosine theta. So we press this X. And then we press graph. And it does look like the function we had here, it's because of the pixels, is not very accurate. Maybe if we trans, but if we press zoom 0, I think we can see better how this was similar with what we got by doing the by plotting the points by hand. This is what we got by plotting the points by hand. Okay, let's do a couple more problems. Let's work on convert the equation below to Cartesian coordinates, describe the resulting curve. So we start with r equals cotangent theta, cosecant theta. Let's change from cotangent and cosecant into sine and cosine, because that reminds us like x equals r cosine theta and y equals r sine theta, so we can work with them and figure out our Cartesian coordinates. So cosine theta over sine theta, that's cotangent, times cosecant theta, that's 1 over sine theta. So we actually get r sine theta equals cosine theta. We just moved the sign on the other side. Now if we notice that this is y, right? So y sine theta equals cosine theta. If we multiply both sides by r, we get y times r times sine theta equals r cosine theta. We know that this is y again and this is x. So we end up with y squared equals x, which actually is a parabola. The graph of this parabola would be, it's a parabola centered at the origin, so this would be the graph of the parabola y squared equals x. And let's try one more problem. Convert the equation below to Cartesian coordinates, describe the resulting curve. We know that r squared equals x squared plus y squared. So if we square this, we get r squared equals 4, which means x squared plus y squared equals 4. So the resulting curve is the equation of a circle centered at the origin, with a radius 2. Let's graph that to see how it looks like. So I'm going to go to y equals, I'm going to clean this, and I'm going to put r equals 2, and I'm going to graph it. So again, we don't see the graph too well, but if we press zoom 0, this is going to give us a better graph. I hope this helps.